This is an extra help video for 3.2 and 3.3. I'm going to go through some examples very similar to the questions in 3.2 and 3.3. Please don't forget to read through your worked examples, especially if you've got that blue box with WE1 or WE2 next to the question first. This is 3.2 question 3. This is an example of how you go about finding your sketch by X and Y intercepts. So at the top here, we've got our equation that we're trying to find. You can rearrange the equation to put it into gradient intercept form, but it's not required. We put our two headings for X and Y intercept. So the X intercept is the place where it crosses the x-axis, and all along the x-axis y's value is 0. So when I let the y value be 0 and solve it, I get the x-intercept. Likewise, all along the y-axis the x value is 0, so if I replace x with a 0 and solve it, I get where it crosses the y-axis. Mark those 2 points and I've got my sketch. Here's a second example. Again, I've got my two headings. X-intercept, let y equal 0, y-intercept, let x equals 0. Replace the x and the y with a 0 and solve it. Mark the 2 points in the graph and join them up with a straight line. 3.2 question 4, and we're sketching using gradient intercept method. So the first thing you have to always check is that you've got one single y equals. If you don't have that, it's not in gradient intercept form, and you've got to do some rearranging. So this one is y equals, and so we know that that's the m value and that is the c value. Y intercept is the point 0, 1. Gradient I'm going to write it as 4 over 1 because I want my rise and my run, so I write it as a fraction. Once I've got those two things, I mark down my y-intercept and then I use my rise and my run. Run is 1, so I go across to the right 1, and then rise is 4, so I go up 4. So that's going to be the point 1. I've gone across 1 on the x, and I go up 4 from there, so I'll get to 5. And I can join them up into a sketch. Okay, so for the second one, check that it's in y-intercept form, and it is. So I write down my y-intercept, I write down my gradient, my m value. Again, I write it as a fraction, so that I've got my rise and my run. Once I've got my two sets of values there, I can mark on my y-intercept at 0, 3, go across 1, and then this time it's a rise of -2, so I go down 2. So that's going to be the point 1, 1. Once I've got those two sketched, I can just double check. Negative gradient, it's going downhill, it's going through 3, we're all good. Just to show you what I was talking about before, when you draw a linear sketch, you really should have both the x and the y intercept always marked. And so if you're not asked to do any particular method, this would be the way that I'd do it. So I'm going to do the gradient intercept method, and that's going to be my way of checking that I got it correct. And I'm going to use my two intercepts to actually draw the graph. So over here, to find the intercepts, I don't really need to rearrange that equation. I just put in x equals 0 for the y-intercept and y equals 0 for the x-intercept. And then I can draw a sketch of the graph. So I've got my x and my y value, and I join them up and I've got my sketch graph. I've also figured out the y equals mx plus c form of this equation. So I subtracted the 2x from both sides, I divided every term by 3, and then I've got my m, my gradient, and my c, my y-intercept. And I use this to check that I've done my calculations over here correctly. So my y-intercept is 4, that's correct. My m is -2 on 3. So for every 3 I go across, I should be dropping 2 to get back to the graph. Run of 3, rise of -2 means I drop 2. Rise negative is a drop. So intercepts to sketch, y equals mx plus c, even if I just do it in my head, but I always do that to check that I haven't made any mistakes. Here's an example like question 5. We're asked to draw a sketch of a graph like that. If I try and find my two x and y intercepts, it actually finds exactly the same point. Both of them are the same point, 0, 0, which is not terribly helpful, because when I draw the sketch like this, I've only got the one point. Where do I draw the line from there? It could be anywhere. So in this case, I have to rely on the gradient. So my y-intercept was +0, if you like. So we've got that. We have to use the gradient now. The top number is my rise, the bottom number is my run. So if I go across 5, then I have to go up 2. Now I know which direction to draw the graph. This is like question 7 in 3.2. We've got an equation here. It clearly is not in the form of y equals mx plus c. So the first thing I have to do is I need to try and get it into that form. So, expand the brackets, subtract 6 from both sides, divide through by 3, and I get my equation in the form of y equals mx plus c, which I can now sketch. If I want to figure out my x and y intercepts, don't forget, I can use any one of these equations. The safest one to use is this one, because I might have made a mistake in my algebra somewhere there. So I'm going to use this one back here to find my x and y intercept. So for x-intercept, I'm going to let y equal 0. So over here I'm going to have 3 outside of 0 plus 2 equals 4x minus 3. And I get 6 equals 4x minus 12. That comes across as a positive, so I get 18 equals 4x. Which will give me 18 on 4, which is the same as 4.5. Y-intercept, x equals 0. 3 pi plus 6, so I'll have negative 3 times 4 is negative 12. And I get negative 6 for my y-intercept. Once I've put my x and y-intercept down, I can now just check this. My gradient is rise of 4, run of 3. So if I go across 1, 2, 3, I should be going 4 to get back to the graph. Looks roughly correct, so I'm feeling confident that I got that one correct. Here's an example out of 3.3. This is questions like question number 1. You're asked to find the equations of these lines. So to find the equation, we need to know two things. We need to know the y-intercept and we need to know the gradient. The y-intercept's pretty easy to find if it's marked on the graph like these ones. The gradient's a little bit trickier. So let's have a look at the red line first. We've got c is equal to 2, the y-intercept. The m is equal to rise over run. So for that, I need a gradient triangle. I always start somewhere on the graph and I have to go to the right. That's important, always to the right. And I keep going to the right until my line is directly above or directly below another known value. Well, here's the only other known value I have. I had to go across 4 units. To get back to the line, I now have to drop 2. So my rise is negative 2, my run is 4, which can simplify down to a half. Since y equals mx plus c, I just put those two values in. The m value is negative a half, the c value is 2. Let's have a look at the second one. C value. The C value is my y-intercept, negative 7. The gradient. I start somewhere on the graph to the left. I go across until my line is directly above or below another known value. Here's my other known value here. So I had to go across 3.5. I had to go up 7. Alright, that's important. My value here is negative 7. That's not what we're measuring. We're measuring how far we had to move. If we have to go upwards, that's positive value. If we have to go downwards, that's a negative value. So over here I had to drop 2, so it was a negative 2 for my rise. Here I have to go upwards, so that's a positive 7 that I've moved there. M is a rise over the run. 7 over 3.5, which is my double top and bottom. That's 14 on 7, which is equal to 2. Y equals mx plus c plus negative 7, or I can just write take away 7. This is an example like question 2 of 3.3. So in this case we've got one where it goes through the origin, 0, 0. To figure out the gradient is actually even easier. I go across here 4 units. I have to go up 3 to get back to the graph. M equals rise over run. My C value is just 0. Y equals 3/4 x is my answer. If you're asked to find the equation of a line not using a graph, but using some information like this, as long as it tells you what the gradient is and the y-intercept is, whether that is in words or describing a y-intercept with a point, then it's simply a matter of putting it into y equals mx plus c. That's your gradient. And your y-intercept is there. So this one will be y equals 6x plus 5. Likewise, this is gradient and y-intercept. Y equals mx plus c. Simple as that. Okay, this example is like 3.3, question 3. And it's using these two rules here. This rule is used to find the gradient that's passing through 2 points, and this rule is used to find the equation. So let's have a look. If the question wants to find the gradient of the line that goes through those 2 points, then the way that we do that is, first of all, we call one of the points x1, y1, and the other point called x2, y2. It doesn't matter which one you call which, it'll work out the same no matter which way you name them. The next thing to do is to simply put it into this rule. So where y1 appears, I have to put the value of 4. Where x1 appears, I have to put the value of 1, y2 goes up there, and x2 goes up there. x2 is 3, take 1. And so I can figure out my gradient. Likewise, to figure out question 2, to find the equation of that straight line, instead of using this rule, I'm now using that rule. So this one is slightly different. Y minus y1 is equal to your gradient x minus x1. Expand that bracket, don't forget to change the sign. Add 4 to both sides. And I get the equation of that straight line. Another example of a question. This is similar to 3.3 question number 5. This is an easier version than the last one, I think, because we've been given the gradient. So we don't have to do this bit of finding the gradient between the 2 points. We're told what the answer is. We go straight to this equation here. So I'm going to let x1, y1 is going to be the point that I've been given, and m is equal to 3. Y minus y1 equals your m value, x minus x1. Expand bracket. Add 4 to both sides, and I'm finished.